Hello students, good evening. So today we'll see the third chapter of PUC first year physics, that is motion in straight line. So what is motion in straight line means a body which is moving in a straight line in a single dimension or a single coordinate. Okay, it may be x axis, y axis or z axis. So here first we'll start the introduction. So in introduction, we have certain terms that we have to know perfectly, first of all, and then we can proceed to the main chapter. So let us see what is mechanics. Mechanics deals with two subjects or branches, that is statics and dynamics. Okay, statics and dynamics are the two branches of mechanics. I repeat, statics and mechanics are the two branches of mechanics. Then what is statics? Statics is the study of the objects at rest. The objects which are at rest, that is known as statics. Okay. And what is dynamics? Dynamics is the study of mechanics or the study of objects which are in motion. Okay. It may be a vehicle which is moving. It may be the planets which are moving. Okay. This is the known as the dynamics. And again, dynamics can be divided into two aspects or two subjects, that is kinematics and kinetics. So as I told you, dynamics can be divided into kinematics and kinetics. So let us see what is kinematics. So, kinematics is the study of motion of the objects without taking into account the causes of their motion. So, for example, planetary motion. So, they are moving around or revolving around the sun from what time, that we don't know. The fixed time is not known, and the motion of the electrons around the nucleus, that is also unknown. So, from when it has started, and the cause, that also we don't know, right? So that is the study of motion of objects without taking into account the causes of their motion is called kinematics. And let us see what is kinetics. Kinetic is the study of motion of the objects by taking into account the causes of their change of state is called the kinetics. Okay, the cause is known here. Okay, so whether it is in rest, and from rest how it has changed to motion, then we can usually say it is a kinetics. Understood? Okay. Okay, let us now see what is meant by a rigid body. A rigid body is a body whose size and shape remain unchanged under the action of external forces. So, a rigid body is a hard body which has a definite shape and size and does not change the size or shape when an external force is acted on it. Okay, and only when it is the resistance of the rigid body, when the force overcomes the resistance of the rigid body, then only it will change its shape and size. Okay, so all are not there is no ideal rigid body still now. So hence we can generally say a rigid body as rigid body is an object whose size and shape remain unchanged under the action of external forces. Motion. An object is said to be in motion if it changes its position continuously with respect to its surroundings with the passage of time. So, motion is an object which changes its position from one point to another point with the elapse of time. So, if a car is at rest, initially at rest, and when the car starts moving, so that is known as motion. It is changing itself, its position with respect to the surrounding. It is moving. So hence we call it as the motion. And let us see what is rest. An object is said to be at rest if it does not change its position with respect to its surrounding, is known as the with the passage of time, is called the rest. Okay, students, let us see the types of motion of a rigid body. The motion of a rigid body can either be translatory or rotatory. Okay, there are two main types of motion of the rigid body, translatory or rotatory. A rigid body is said to have translatory motion if it moves in such a way that all the particles of the body have the same direction of motion at all instants of time. So if the applied force is one side, the all the particles will be moving in the same side. Now but we are talking about the single straight line motion. Hence a stone dropped from a certain height, that is a translatory motion. Okay, the particles of the stone will be moving in a same direction. Okay, so that is known as the translatory motion. Now a motion of a rigid body is said to be rotatory if it moves such that the line of particles in it remains fixed with respect to the surroundings and all the other particles describe circular paths. For example, a top rotating. Okay, the axis of the top will be having the fixed particles moving in that same direction, and the neighboring particles will be having the different direction, the circular path. So for example, we can take here a wheel or a pulley in motion has rotatory motion. A wheel which is rotating, that is a potter wheel which is rotating, the center part of the wheel will be fixed, and the neighboring parts, that is the spokes of the wheel, it will be rotate having a circular path, right? A pulley in motion, a pulley is the thing where where it is applied to near in at the well to take water. The rope is hanged through the pulley so that we can pull the pot from the well upwards, or put the pot the into the well in the to take the water. Okay, with the help of the pulley we can lift the pot. Okay, pot of water. So this is the translatory motion and rotatory motion. Students, let us see what is frames of reference. Frames of reference are nothing but the mutually perpendicular axis, that is x-axis, y-axis and z-axis, that define the or locate the position of the particle or object. Okay, so these are known as the frames of reference. Frames are reference are the x-axis, y-axis and z-axis. Okay, and that specify the position of the object with respect to that frame. So if all the three coordinates, that is x, y and z coordinates, are remain unchanged with the passage of time, then the body is said to be at rest, or the object is said to be at rest. So what is a frame of reference? Frame of reference is the coordinate axis which are perpendicular to each other. So I have drawn here figure. So x-axis, y-axis and the z-axis. X-axis, y-axis and z-axis, they are mutually perpendicular to each other. So if a body is somewhere in the xy plane, then at how much distance away it is from along the x-axis, and how much distance away from along the y-axis. Okay, and due to from these all we can tell in which dimension also it is, whether the body is in a straight line or in a plane or in space. Okay, so that we will define next, that is the one dimensional motion, two dimensional motion and three dimensional motion. So let us now see one dimensional motion, two dimensional motion and three dimensional motion. So first we'll see the one dimensional motion. In this type of motion, only one of the three coordinates specify the position of the object which changes. Okay, object changes. Example, the object moves along a straight line. For example, freely falling body under the gravity. So if you throw a stone upwards and when it falls downwards towards the gravity, then that is a one dimensional motion. Okay, so one dimensional motion is a motion in which only one of the three coordinates will be changing with respect to the body and the surroundings. So that is known as a one dimensional motion. Next, let us go to the two dimensional motion. Two dimensional motion, in this type of motion, two of the three coordinates specify the position of the object changes. The object moves in a plane. So whichever object which is moving in a plane is known as the two dimensional motion. Example, motion of an object in a vertical or horizontal circle. Okay, motion of a projectile. Projectile is throwing of a ball, right, from one point to another point. That is a projectile motion with a certain angle. And third one is the three dimensional motion. The motion of the object in which all the three coordinates specify the position of the object changes. The motion of the object is not a straight line or a plane, but it takes in space. So here in all the axes, that is x-axis, y-axis and z-axis, will be changing with respect to the surroundings in a body. For example, a bird flying in the sky, an aeroplane flying in the sky. Okay, these are the three-dimensional motion where all the three coordinates contribute to the motion of the particle, right? The rocket in the space, planet moving in the space, these are all three-dimensional motion. Thank you for watching the video. Please subscribe to my channel and view more my videos.